This video is going to show you how to balance reactions, and there's really only one rule for this, that you can only change coefficients. And coefficients are the numbers in front of the compound, not the little numbers that are below. Those little numbers are called subscripts. So don't ever change the subscripts to try to balance the reaction, and you can only put coefficients in front of the compound. You can't stick them in the middle. So let me go through a few examples with you. The whole idea is that we're going to cut this reaction where the arrow is. The numbers on the left have to equal the numbers on the right. So for example, if you take a look at aluminum, on the left of the red line we have 1 aluminum, and on the right we have 2 aluminums because of that little 2 down there. So we need to fix that by putting a 2 in front of this compound here. And now we have 2 aluminums on both sides. The next thing we're going to go to is copper. We have 1 copper on the left and 1 copper on the right, so it's already balanced. And the last thing we need to balance is the SO4. Now here's the thing. If you have a polyatomic ion on both sides of the arrow, you can just keep it together as a unit. So instead of balancing the sulfur separate from the oxygen, which would be way more complicated, you can just balance it as a unit of SO4. And be careful here, it looks like we have 4 SO4s, but remember it's really just 1. If there's no parentheses around a polyatomic ion, you just have 1 of them. So notice we have 1 on this side we have 3. So we need to balance that. And the only way to fix that is by putting a coefficient in front of the compound. So we're going to put a 3 here. Now when you have a coefficient, that number goes to everything in the compound. So now we have 3 coppers and we have 3 SO4s. That was good for SO4 because now we have 3 on both sides. However, notice we also put the 3 in front of copper, so now we need to go back to the side and put a 3 in front of copper to fix that. And now we should have the same number of everything on both sides of the arrow. You can leave that last blank just empty. It's really a 1 there, but we just don't like the 1, so scientists would just leave that empty. All right, let's do a few more. Feel free to pause this anytime if you need to let it soak in, or if you want to try one by yourself and then check your answers. For the next one, we're going to check hydrogen first. I usually just go left to right, but it really doesn't matter what order you do the elements. So we have 2 hydrogens on the left and 2 on the right, so it's already balanced. Now let's go to oxygen. We have 2 on the left, and we only have 1 on the right because there's no subscript next to oxygen. The 2 in water only goes to the hydrogen. So what I'm going to do is put a 2 in front of the compound, and that 2 will go to both the oxygen and to the hydrogen. Now here's the thing, if you have both a coefficient and a subscript, you have to multiply them. So when you multiply that, you get 4, so we need to have 4 hydrogens on the left. However, we're not going to put a 4 because whatever number we put on that blank, we're going to have to multiply by the subscript. So we're going to put a 2 so that now we have 4 on both sides. All right, let's look at the next one. This time we have 1 zinc on the left and we have 3 on the right. So I'm going to put a 3 in front of zinc to fix that. Now we're going to go to OH, and here's the problem. I don't see OH on the right, but this is a little trick that can help you. If you have OH on one side, and on the other side you have water, you can rewrite water as H separate from OH, and then you can balance the OH as a unit. So let's go ahead and do that. You won't always change water to HOH, but you can if you have hydroxide on one side. So now we're going to balance this H separate from this OH. And on the left side, be careful, you have both a coefficient and a subscript. So we actually have 6 OHs on the left, so we need to have 6 OHs on the right. So now zinc is completed, hydroxide is completed, we're ready to move on to the next thing, which is hydrogen. We have 3 hydrogens in the H3PO4, and on the right we have 6, because remember we're going to treat hydrogen separate from OH, and the 6 goes to both the H and the OH. So that means we have 6 H's on this side, so we're going to put a 2 in that blank, so that 2 times 3 gives us 6. And the last thing, let's just check that last compound. 3 zincs we already fixed. We have 2 PO4s, and we already fixed that PO4 because that 2 goes to that whole compound, so now PO4 is good as well. So you can just leave that last one blank. All right, let's look at the next one. We have 2 silvers on the left, so we need a 2 on the right to fix that. Sulfur, we have 1 on the left and 3 on the right, so we're going to put a 3 here. But notice that as soon as I did that, that changed the silver because that goes to the whole thing, so I'm going to go back and fix that. And now we should have 6 silvers. And then the last one is aluminum. We have 1 on the left and 2 on the right, so let's put a 2 here. And everything should be balanced. This next one, sodium is already good. We have 1 and 1. Iodine, we need to put a 2 here to fix that, and then that changes sodium, so we just need to put a 2 here. All right, 4 more. These are going to get a little more complicated, so stay with me, and feel free to pause the video or watch it again if you need to. This next one looks complicated because we have a lot of stuff going on there, but notice that we have some polyatomic ions that we can just treat as a unit because they're on both sides of the arrow. So let's just start with calcium. We have 3 on the left, so let's put a 3 here. Phosphate, we have 2 on the left because of this little subscript 2 right here. On the right, be careful. It looks like 4, but remember it's really a 1. If there's no parentheses around a polyatomic ion, you just have 1 of them. So to fix that, we're going to put a 2 in front so that now we have 2, because remember that 2 goes to both of them. So calcium is good. Phosphate is good. Let's move on to hydrogen. Right here, we have a big number and a little number. Don't forget to multiply those. So now we have 6 H's on this side. We're not going to put a 6 though because we want it to equal 6. We're going to put a 3 because now 3 times 2 will give us 6. And then I think sulfate fixed itself because we have 3 on both sides. Both of those big 3's go to the sulfate. All right, this next one is a common problem you're going to see quite often. So K is good, Cl is good. We just have 1 of those on both sides. But notice the oxygen. We have 3 on one side and 2 on the other. So when you have numbers like that, what you need to do is find a number, a common number that they will both go into. And the smallest number that 2 and 3 will both go into is 6. But we're not going to put a 6. We're going to put a number that will multiply to give us 6. So on this side, we're going to put a 3 because 3 times 2 is 6. On this side, we're going to put a 2 because 2 times 3 is 6. So now they match. And then the last thing is we just need to fix K and Cl. So now this 2 goes to the whole thing. So now we have 2 Ks, 2 Cls, and 6 oxygens. So if we put a 2 here, that should fix that as well. All right, this next one, oxygen is the troublemaker. And let me just say, if you can save oxygen for last. Oxygen tends to be the one that's the hardest to balance because it tends to be in a lot of compounds. Notice that it's in all 3 of these compounds right here. So what we have to do, here's the cutoff. We need to make all the oxygens on the left equal all the oxygens on the right. So right now we have 2 here, and 2 here is a total of 4. Over here we have 3. When you get to a problem like this, and you're like, oh my gosh, I don't know what to do. We've got 4 and 3. How do I know which oxygen to change? There's 3 different compounds. What I want you to recognize is that you have an even number and an odd number. And when you have that issue where you're not sure what to do, but you have an even number on one side and an odd number on the other side, you're going to multiply the odd number by 2. Try doing that, and sometimes that will fix your problem. When you multiply it by 2, it will make it even, and that way it'll be easier to balance it. So our odd number is that 3, so let's put a 2 here to make that an even number and see what happens. But our other rule is what I put up there, save oxygen for last. So before I try to fix oxygen now, notice that I just messed up sulfur. So always try to save oxygen for last. So we need to fix sulfur before we go back to oxygen. So if we put a 2 here, now sulfur is good. Now we're finally ready to reevaluate our oxygens. On the right side, we still have 3, and then times the 2 in front gives us a total of 6 oxygens. On the left side, we have 2 right here, and then don't forget, if you have a big number and a little number, you multiply them. So you have 4 in this compound, plus 2 more will give us 6. And so oxygen worked itself out without working too hard. If you can use that little trick where you multiply the odd number by 2. All right, last one. This is a combustion reaction, and I want you to recognize that you have C, you have H, and then you've got a separate oxygen. That's one of the clues that it's probably going to be combustion. In a combustion reaction, you're always going to get CO2 and water as your product as well for this class. It's not always in real life, but for this class it will be. So I want you to watch out for, we'll call it a CHO reaction, and I want you to do it in the order of CHO. Do carbon first, then hydrogen, and like I said, save oxygen for last. So let's go ahead and start with that carbon. We have 3 on the left, so let's stick a 3 right here. Then we're going to move on to hydrogen. We have 6 on the left. We have 2 on the right, so if we put a 3 here, that will give us a total of 6. And now we've got that troublemaker, we've got that oxygen. So be really careful, you've got big numbers and little numbers, and oxygen is in 3 different compounds. So first of all, notice that we only have, this is our cutoff right here, the arrow, we only have 2 on this side, but over here we have 3 times 2 gives me 6 here, plus another 3 here is a total of 9. So now we're at that point where you're not sure what to do. We've got oxygen in lots of compounds, but if you can notice that we have 2 on one side and 9 on the other, this is that odd even issue where you're going to do this right here. You're going to multiply the odd part by 2. Don't put a 2, multiply it by 2. So 2 is an even number. Right here was 6, that's an even number. It's this 3 right here that's making it odd. So like I said, don't put a 2, you're going to multiply it by 2. So let's multiply that 2 to make it 6. And then the other rule is way up here. Keep following these rules and it will get you through this. The other rule is to save oxygen for last. So while it's tempting to try to go ahead and finish up oxygen, we just messed up hydrogen by putting a 6 there when we multiplied that 3 by 2 to make it even. So before we go to oxygen, we need to fix everything else. This 6 now changed hydrogen. So now we have 6 times 2 gives us 12 hydrogens over here. So we need to put a 2 on the left. All right, hydrogen is good. Let's go ahead. No, now we messed up carbon though. So notice now we have 6 carbons here. So let's change this one to 6. And now everything should be balanced except for oxygen. And you should have an even number of oxygens on the right side. Let's see what we have. We have 6 times 2 here is 12. 6 times 1 is 6. So we have a total of 18, which is now an even number. And so now I can put a 9 right here because 9 times 2 will give me 18. That's about the hardest that you're going to have to do for this class. So if you just understood that whole process, you're probably good to go. If you didn't understand it, I encourage you to rewind the video and go ahead and watch it again and just keep watching the thought process and hopefully it'll sink in. And we'll go over some more balancing examples during our live meet as well.